Hello, everybody. Welcome to our talk, Real-Time Data Updates for Neo4j using GraphQL Subscriptions. We will be kind of having some demos, which we kind of hope you get engaged with a bit later. So if you're not connected to the Wi-Fi, GraphConnect 22, these are the credentials. I believe this is just kind of a bit of like a Faraday cage for any 4G or 3G in here. So get that sorted out, and then hopefully we can get on that later. Cool. So my name is Darrell. I'm a software engineer at Neo4j. I work in the GraphQL team with my colleague, Andrés.
Yeah, I also work in Neo4j, GraphQL team, and I enjoy beer, as you can probably see.
Cool. So, first of all, I tend to, with these talks, always do like a what is GraphQL section. Like, hands up, who is familiar with GraphQL? Are you? Yes, you're here because you know GraphQL, not because you're interested in real time. This is cool. So we can probably like breeze over this, which is probably going to really shorten this talk, but we'll see how it goes. So GraphQL, it's a language, it's a runtime where you can, as you see, kind of describe your data in like a nice kind of type-safe manner. It's really kind of nice and easy to reason with. You ask for what you want and only what you want. So here we're asking for a project called GraphQL and only the tagline of that project. And then that is all you'll get back. So you're not kind of, there's no overfetching, much like with REST. It was invented by Facebook because they were kind of struggling in 2012 with mobile data. They were just getting way too much data back for kind of building mobile apps when they were kind of loading the news feed. So they invented this as a way of kind of saying, when I'm getting the newsfeed, I just want to get exactly what's being presented to the users, reduces kind of usage of mobile data, makes everything feel a bit snappier and more performant. And then it was open source in 2015, and people have been building great things with it since. So it's all kind of built kind of upon type definitions. So you can, for instance, in here we've got type movie, which has a title and a runtime, and then we can define a query where you can query a movie by a title, which is a string, and you get a movie back. But you know, there's more advanced stuff you can do. You can add in actors. You can go from actors back to movies via an acted-in kind of field. There's also directives. Deprecated is one that's built into GraphQL, so you can kind of add in metadata into your schema. Allows you to do interesting things with the schema. And then with those type definitions come resolvers. You can see here for that movie query we had before, we might just define a simple function like this. As you can see, it's like a perfect shaped map to what was defined in the type definition. So you've got query, and then the movie field. That takes a function, and then you kind of can find a movie from a database or a data source or wherever that might be coming from. And then you have the query language. So with this one, you can see this is the operations. So it's a query operation. The name of the operation is find movie in this case. And then movie is the root level field that we're going to go and fetch. And you have arguments. In here, we're going to look for the terminator. And then finally, the selection set, which describes what you're going to be kind of fetching back from that GraphQL API. And I think the other kind of core kind of thing to keep in mind is operations. There are 3 operations in GraphQL. There is query. These are kind of read operations on a GraphQL API. You have mutation, allows you to kind of create, updates, deletes, mutating data in your GraphQL API. And finally, subscription, which is why you're all here now to listen to what we've been doing in the GraphQL library related to this. And I'm going to pass over to Andrés, who's going to give a short demo to show what you can do with subscriptions.
I'm doing the things that can break.
Next. There we go. Wait.
It was seamless. It was completely seamless. So let's see if this. Oh, lovely. So subscriptions. Before anything, a little quick showcase of what these are usually used for in GraphQL, regardless of Neo4j or library or anything. Basically, we have right now 2 clients, right? Both are rendering this lovely web page front end. I can do freelance websites for you if you want. So this is running. This is showing in a table the movies database that is, a classic example. And what we can do is edit this data. So if a client edits the description of this movie, so removing this, for instance, you can see that the other client effectively is receiving the update and the change immediately. This, of course, works. Oh boy. Oh. Okay.
Don't click lighter.
This is something that goes both ways. So basically, every client connected to the server will receive updates when a mutation is happening. And this is done through subscriptions. It's the common use case. This is the magic. We will talk later about how this is built. But in order to get to that, before we need to talk about, and you're going to talk about, how GraphQL is built within Neo4j using the library.
Yeah, for sure. So, I mean, Michael's already kind of talked about this a bit today in the keynote. So once again, I'll kind of breeze through it. But we have the GraphQL library, which is kind of a core product coming out of the GraphQL team at Neo4j. This is a library that sits between a GraphQL client and a Neo4j database. And it's essentially doing the moderately tricky job of translating GraphQL into Cypher to open up different options for querying a Neo4j database without having to worry about Cypher or kind of specific graph database technologies. Kind of one of the problems which this library tries to address is boilerplate, right? This is what you want to define. This is your domain. You have a movie with a title. But with GraphQL, you've kind of got to define all of this, like a query if you want to query a movie, mutations, maybe add movie, change movie, remove movie, and then underneath all of this, you're going to have to define all of the resolvers as well. It's a lot of work. So we say no to this. This is rubbish. We don't want to be defining all of that ourselves. We just want to worry about a domain and then have the rest of it generated for us. Type definition boilerplate is bad. Automatic schema generation is where it's at, and that's what we achieve with the GraphQL library. So purely by defining just a type movie with a title, which is a string, we get all of this. We get all of these queries. You get to query movies with a ton of options, with a ton of filtering options as well. You can do aggregate queries. You can do connection queries, which if you're familiar with the relay specification, allows you to do cursor-based pagination and get relationship properties. You get all of these mutations. You get create movies, delete movies, update movies. All of this is done for you. The resolvers are there for you. So you just need to pop this into a GraphQL server and away you go. You can start building a web application without having to worry about any of this. And then finally, with the kind of updates in the library recently, you now get a bunch of subscriptions which are added as well. So you now get a movie created, movie deleted, and movie updated, which is every time this event happens to the movie entity, your kind of connected clients who have connected to the server via WebSocket will get those updates. And then kind of the magic source of the GraphQL library, which is what we spend an awful lot of time on, is Cypher translation. So when you see a GraphQL query like this, you can imagine how we might work through the Cypher translation to get to where we need to be. So you can see that we're querying the movie field. So we can say we're going to be matching M to a movie label in the database. The arguments can go into filters. So we're saying where the title is the terminator in GraphQL goes nicely into Cypher as where M title equals the terminator. And then finally, that selection set translates like it can really nicely into a projection in the Cypher. And we only ever return exactly what needs to be returned from the database so that it's nice and performant for fetching data. And I was going to give a bit of a demo of exactly what Michael demoed this morning. So what we'll do is we'll breeze through it anyway. You know, maybe. Yeah. So. Yes, so you've seen the GraphQL toolbox in the keynote this morning, and that was a pleasant surprise. Thanks for that, Michael. You've kind of seen some of what can be done in there already. So here I've defined some type definitions which match to a very similar attendee graph to what was presented earlier. I don't believe the database I'm connected to has Google Cloud Service names. I think it's a different anonymized data set. So you can see we've defined type attendee. We've used this directive here. So exclude kind of says, I don't want any create, update, or delete operations to be added to the mutation. We have a bunch of these directives. You know, we can quickly click on the help here and go to directives. You can see that this is kind of the real core of how the GraphQL library works. And that's by kind of adding in these directives which give extra power to the type definitions that you're defining. So you can see here there's ways you can inject custom Cypher, you can set default values when things are created or updated, exclude, you can remove things from the generated schema, You can define indexes and constraints. Full text indexes are supported. Unique no property constraints are supported. Just a bunch of stuff that kind of added power using directives, which can be really useful. And then with the toolbox, we can just hit build schema, and this will take us through to a nice query window, and we can just run like an attendees query, and we can, oh no, it is this one, there we go. What a surprise. So, we have the same like names as we had here this morning. Yeah. So, but you can kind of do some other stuff with this tool as well. So you can see here I've got enable debug checked, and you can actually kind of go in here and you can crack open a console. You'll see a bunch of red stuff, but you know, we can quickly clear that, and then we can run this. It's going to be a little bit small on that projector, but you can see the generated cipher right here. So you can see on the top the query that's coming in, and then the cipher that we've generated from that. This kind of, you can basically play around with this. You can make a really kind of complicated GraphQL query and see how that's all going to translate down into cipher. I think that's super cool and kind of really nice to see what's happening under the hood. And then also in here, you've got some autocomplete stuff, so you can kind of, you know, add in job function, last name, participant ID. It's all kind of pretty slick and a really nice way of playing with the GraphQL library. But I won't dwell on this for too long. I think we've all seen quite a fair amount of GraphQL during this conference so far. So I will pass over to Andrés, who's going to talk about what we're actually here to hear about.
Subscriptions, a deep dive. So I'm not used to revealing my tricks, but you know, I have to do it. So you've seen how the previous example, the one with the movies, was working. So now we're going to do a deep dive into how that's achieved with the library that Darrell just mentioned, and Neo4j. So for starters, GraphQL subscriptions, regardless of how are you building or whatever, just if you are using subscriptions. The idea is basically that you have a server, you have your client, the client can send a subscribe request, and after that request happens, there is some way the server will keep sending events to your GraphQL client. The GraphQL standard does not really define what transport is going to happen, so it can be whatever up to the server. In the real world, it's usually WebSockets, but not always. The core definition is that one subscription will keep receiving events until that connection is severed, basically. The same, now not in a diagram, now with the actual subscription query that you will get if you use the Neo4j GraphQL library, with the example that you've already seen with the movies. So in this case, this is the subscription operation that is sent at the beginning by both clients. Just like with everything in GraphQL, you define exactly what you want to receive, and the events that you will get will match that definition, basically. So here we're saying, hey, I want to get the movie created events, and from that event, which triggers quite obviously whenever a movie has been created, I want to get the movie itself. There are also some extra metadata that you may want to query, and in particular, I want the title. So here you can see that you start receiving events whenever a new movie has been created, and it will keep sending you events. The same idea can be done for updates and deletes, which are basically the different mutations that we support. Actually, any mutation that happens. So how this is achieved exactly in the Neo4j GraphQL library. So we have now, in this example, in this lovely diagram, our server right here, which is basically running the GraphQL server, and it has the connection to the database. And then we have two clients. One of them, the client on your right, has a subscription that they opened at some point, and then at some point in time, a second client performs a mutation. The Neo4j GraphQL library will trigger that mutation into the database, doing the translation that Darrell already mentioned. And once that transaction has happened successfully, then it will trigger the events to any subscribed client. So the key takeaway here is that the subscriptions are triggered after the database mutation have happened. That's quite important, consistency. So let's deep dive a little bit more into this bit, the second step, the actual translation, because that's where a lot of magic happens in order for this to be performant.
Yeah, so we can call back to what I kind of briefly talked about before, which is how this translation works. You can see here there's a mutation, create movies. We're going to create a movie for Hot Fuzz, and we're going to get the movies and the title back. So you can see on the right, this is the translation that before subscriptions were added was happening. So we have a nice little subquery. We're running a create of movies. We're going to set the title to Hot Fuzz, return that movie, and then there's a nice projection at the end to just return the movie and that title as the data that's going to be returned to the clients. However, in subscription land,
this is the new query. When you basically set subscriptions to be active, it's an opt-in feature. Every mutation that happens through our library will add all of this extra metadata. This is basically a variable that includes what has happened, what kind of mutation, the timestamp, and the properties of the node that has either been created, updated, or deleted. This extra metadata has two important implications. The first one is that only mutations that are happening through our library will be reported by the subscription system. So if you run a custom cipher, there is absolutely no way of knowing that something has happened, which is sadly a limitation. The second, much interesting and hopeful result of this is that no extra queries happen behind the scenes. The properties are returned directly when the mutation happens. That means that it doesn't matter if you have one subscriber or 500, there will be absolutely no extra request to the database. That means that the database itself won't have a huge load if you have a lot of subscriptions, which is quite important because it can be quite a heavy load if you try to, for every change, also multiply the number of requests. Going back, a few details on how this is built. Mainly, I need to mention that we have built this with being agnostic in mind. So that means that we are only relying on things that are as standards they can be in the GraphQL area. So things like transport are something that is up to the server you are running the Neo4j GraphQL library on. And that will be need to set up depending on what server you use, whether it's Apollo or Yoga. And this is basically how subscriptions are built with the Neo4j library.
Cool. So my startup has been extremely successful. I have millions of users using this crazy kind of real-time data system that I've built. Does anyone see the problem here? This isn't going to scale. Like when I want to horizontally scale this, how's that going to work? If the client on the left is sending things to instance one, but then if there's another instance over here, how's that going to work? How are the events from instance one going to get to instance two? Surely this is impossible.
Well, that's a great question, Darrell. What are the odds? The next slide resolves that question. So the problem that Darrell just mentioned is actually a problem that will happen with almost any real-time system that you try. The moment you have a permanent connection between a client and a server, essentially your servers are no longer properly stateless. And that's usually a problem when you try to horizontally scale. So in this example, it's really similar to what you have seen. However, now we have two servers running the Neo4j GraphQL. So one client is subscribed to one of the servers. That's up to the gods of the algorithm to balance. And the second one is doing a mutation. However, they're doing it in a different server. The mutation will come through. It will do the update in the database. It will retrieve all the metadata. The other server just doesn't know anything about what's going on. So we are missing some kind of connection here. How do we solve that? One of the most common ways of solving this problem, it's not the only one, but one of the most elegant, in my opinion, is through a third-party broker. So the diagram is now a little bit more complex, but I think most of you can easily follow. The mutation happens with a query, just like before. However, now the library, instead of just sending the events of the subscription, will take that metadata and set that to a third-party broker. This can be RabbitMQ, it can be Redis, it can be Kafka, or whatever broker works for you. And then this broker will basically broadcast this event to all of the Neo4j GraphQL servers. And then each server will take care of their own subscriptions by filtering, adapting, checking authentication, or whatever is needed. They will do it themselves. So each server only knows about their own subscriptions and just whatever comes from the third-party broker. And Yeah. I had to do it. I'm sorry, I had to do it.
But surely the setup for this has to be really difficult.
Well, not really. It's actually super easy. Barely an inconvenience.
Oh, really?
Yeah. The whole library, I'm glad for the 3 people that laugh. The whole library is built with this already in mind. So the library is built basically, the way you set subscriptions to be active, setting up the library, is by a plugin system. So this chunk of code, for whoever is not familiar, is basically the code that you usually do to set up the Neo4j GraphQL library to create an schema that will be fed into your GraphQL server. The new stuff is this lovely plugin in which we're saying, hey, I want to import this plugin, that's a package in lovely npm package, and I want to use ANQP with this setup, that's my RabbitMQ server. You can use whatever ANQP 0-9-2 or whatever the version is you want, and just set the plugin there, and that's it. Granted, there is a little bit more code involved. You need to set up our ANQP server. You need to add a few of the fiddly things that you may need depending on what server you're using. So set up subscription for Apollo, WebSockets, and all that good stuff. But when it comes to the library, this is all you need to run a fairly stable server with horizontal scalability.
Question back here.
Yep.
So the messages that you're passing through here, are they specifically and proprietarily formatted for the Neo4j broker? Or could you have any listener be listening to that queue and off Neo4j and off GraphQL system also receiving and processing those messages in a separate system?
You could do that, yeah. It's just sending.
Is there any prior art in other GraphQL subscription systems where, like in the CBC world, there's Division, for instance, is there something similar in the other subscription system from the other GraphQL libraries? Have you looked at it?
I think we looked at all of the pub sub stuff. I think the reason we've taken this approach is, well, everything's kind of Apollo, it's super Apollo specific, and some of those libraries haven't been updated in a year. It's kind of like...
Is there some kind of joint format that kind of is similar across the library?
It's a plain JSON. It should basically run with whatever. The plugin itself takes care of the format of the coding and decoding. And yeah, the plugin system is basically, it's not using PubSub as Darrell said, because we are quite invested into trying to make this agnostic as possible. Also, the plugin system is well documented how to create your custom plugins. We right now only support local and ANQP, but I can tell you by experience that it took me I don't know, 1 hour to create a Redis plugin, and likewise, it's extremely easy to create a plugin that is compatible with the Apollo PubSub or whatever. So that shouldn't be a problem, and we hope to support more plugins in the future.
So is in the broker, and you're using PubSub, I can't remember, but generally it's not guaranteed delivery. Like when you're talking about a distributed system and stuff like that, what kind of guarantees are made in terms of message delivery?
That's basically up to what broker you're using. Our library basically tries to be agnostic of what you are running. So basically, the plugin just cares of decoding, encoding, and connecting. So for instance, with ANQP, as long as the broker is up, I think delivery is guaranteed with the setup that we had set in this plugin with ACK and all of that. But at the end of the day, it depends mostly on the broker and the overarching architecture that you're using. Now, that was a spoiler, but yeah.
Yeah, I think so.
We're going to change a little bit to a completely different topic.
Yeah, I mean, before we move on, any other questions kind of about this whole subscription stuff before?
I mean, as long as you have the ability to build your own custom plugin there that ties into the event system, that's wicked cool.
Yeah, it was designed with that in mind because after investigating a lot into how PubSub works in other servers and things like that, we tried to go for something standard. There is no standard. So yeah, you basically, at the end, one end is sending a JSON, and the other end is receiving a JSON. What's in the middle with the broker? It can be encrypted or whatever. That depends on your plugin.
Has anybody talked about using
In what, sorry?
Audit framework. So literally, if you've got these end clients that are making changes back into your graph, back and forth, and you've got the passing, and you have to tie into the event bus now that all of those events are being passed through, you could offline your audit trails for all of those changes into a separate system and completely eliminate any loading on your Neo4j backend system in that case.
I think the
Only as long as you can guarantee that all operations are going through the GraphQL system.
Yep, that's the
yeah,
limitation.
that's about,
It's just a
yeah.
design question that drives it, but it's a fascinating thing to tie into that event chain in between the client server at that point of integration.
Yep, that would be doable. You can set up the plugin and store that in disk or wherever, that audit. In fact, one of the demos that we're going to show now has the logs for every event that's going on. So yeah, that's doable. I really never thought about that because that would have that limitation of needing to go through GraphQL, but it's a really interesting idea.
Yeah. Cool.
Any other question? There will be more chance for more questions afterwards as well, so no rush.
Cool. So we're going to move away from subscriptions and have a small kind of overview of kind of a cultural phenomenon. For a few years ago, in 2017, April Fool's Day, Reddit created someone on Reddit created the r/place subreddit, which was a kind of collaborative experiment, I guess you could call it, on Reddit, where for a period of, I think, 3 or 4 days, you could add a pixel to this canvas, which you see here. This is the end result of what was there. You add a pixel, and then there was like a 5, 10, 20-minute delay before you could add another pixel. Yet, amazingly, with that delay, this is the result, this kind of amazing kind of piece of art, which is kind of collaboratively done by an online community. And this happened again in 2022, once again on April Fool's Day, and also again kind of producing amazing results. We thought this was really cool, and we thought, what an amazing kind of thing could it be if we could build a similar collaborative experience using Neo4j GraphQL. So we were busy, and Andrés mainly, I will happily give the credit, kind of was busy working on Neo Place, which we'd love for you to try out.
Before anything, who here was already familiar with Reddit Place? Hands up. Okay, quite a fair amount of people. Well, you have that QR code, and I hope you have, connection, internet connection here. Also the URL if someone is using a laptop or whatever. So if you go there, you will see, hopefully, if everything's working, this. Oh, it's already happening.
And there we go.
Yes. So this is a much smaller canvas, and there is no limitation. So. Please don't draw anything that shouldn't be there. This is built just not only as I think, a really cool demo of real-time updates, but also this is to showcase how easy it actually is to build something like this with the setup that we just discussed. This is running on an Aura-free instance. It is running on App Engine, so it automatically scales this Neo4j GraphQL server. It's right now at 2 servers, if I'm not wrong, but if more people keep connecting, it will scale. And we're using Cloud ANQP, the free tier, to handle this as a broker. Regardless of frontend, the frontend is a bit more complex. The whole server setup is roughly, 50 lines of code or something like that. Just get the plugin, connect to ANQP, and define the type definition for this canvas, which is actually being stored right now in Neo4j. So this is how the database looks right now. Each pixel is a node, in case someone is wondering. And I love how everyone is drawing things.
That means you can also use Bloom with the XY code attached to render as a
Using Bloom.
color graph.
Yes, we tried that. Bloom set up with the grid system, and it actually works quite well. Sadly, Bloom does not support subscriptions, so you cannot see the real-time magic happening.
Not yet.
Not yet, not yet. It will, hopefully. So yeah, this will be up for, a few days at least. So you can feel free to play around, tell your friends, draw something cool, hopefully wholesome. And that's, and also you have access to the GitHub, the documentation, and the Discord community there. So feel free to reach out to those links to learn a bit more about the whole library. And also, I think you wanted to say something about the community?
Yeah, so all of this is free. All of this is open source on our GitHub repository, Neo4j/GraphQL. But I also want to say we could have never really built any of what we built here without the help of the community. This was kind of actually originally implemented by a community member before we kind of took it into the product engineering teams ourselves. So there's been so many great contributions to this library by our community, and we welcome you all to join as well. Please, raise bug reports, ask us for features, build features, fix bugs. We love it. We love working with the community, and yeah, it's a big reason of why we're here now. Thank you for coming to this talk. We'll happily take any more questions if there is any.